You are welcome to today's class. In today's class, this class, I will be putting you through Crammer's rule. How do we solve simultaneous equation or linear equation? How do we solve linear equation using Crammer's rule? 2 by 2 and 3 by 2 matrices. Let us take Crammer's rule. Crammer's rule provides a simplified method of solving a system of linear equations through the use of determinants. It provides a system of solving linear equations through the use of determinants. Crammer's rule states that this is the formula for Crammer's rule. The A is biota, which is unknown variable. This is an unknown variable. Unknown variable. Why? This is a special matrix. This is a special matrix. Why? This is the determinant of coefficient matrix. The determinant of coefficient matrix, the special matrix, and the unknown variable. Unknown variable. Now, using Crammer's rule, we say that Crammer's rule equals to the unknown, equals to the special matrix divided by the determinant of coefficient matrix. This is the special matrix and this is the determinant of coefficient matrix. Denominator is the special matrix. Why? The denominator, the determinant of A is determinant of coefficient matrix. Determinant determinant of coefficient matrix. Let us look at example 1, where we are to solve the system of equation below using Crammer's rule. Example 1 says that solve the system of equation EG1 solve the system of equation below using Crammer's rule. 6x1 plus 5s subscript 2 equals to 49. Now we have 6x subscript 1 plus 5s subscript 2 equals to 49. While 3s subscript 1 plus 4s subscript 2 equals to 32. So we have equation 1 and this is our equation 2. Now to solve this using Crammer's rule, the first thing we look for here is the determinant of x1 and the determinant of x2, which we call x subscript 1 and s subscript 2. But before going to that, let's express the equation in matrix form. Express the equation in matrix form. Expressing the equation now in matrix form will now give us 6 and 3 here. 6, 3, 5, 4, x1, x2, that is for the x1 and the x2, equals to 49 and 32. So we have 49 and 32. Now, we now want to look for the determinant of x1, determinant of x2, and the determinant of a, before we can now proceed to get what our x1 and x2 is. To look for the determinant of x1, determinant of x1 equals to, when we are looking for the determinant of x1, we now come back to this place, because this represents x1 and this 5 and 4 represent x2. So when we are looking for x1, we have to eliminate these x1 figures. So we use it with equals to figure, which is 49 and 32. Then we use 5 and 4, which represents x2. Now, the next thing we do here, after getting this, is to say determinant of x1, which equals to, then this multiplied by this, 49 times 4, the invisible minus that is there, minus, bracket open, 5 multiplied by 32, which equals to 49 times 4 will give us 4 times 9, 36, carry 3, 4 times 4, 16, plus 3, 196, minus 5 times 32, 5 times 2, 10, 0, carry 1, 5 times 3, 15, plus 1, 160, which equals to 196 minus 160 will give us 36. That means that the determinant of x1 equals to 36. Now we look for the determinant of x2. The determinant of x2, in the determinant of x2, this is x1 figure, 6 and 3, it contains 6, 3. Then 5 and 4, which is representing the x2, have to be replaced with 49 and 32. Simply because we are looking for x2. So it will not occur here again. We now say which equals to 6 times 32, the minus sign that is here, then 49 times 3. We now have it like this, which equals to 6 times 32, 6 multiplied by 2, 18, carry 1, 6 multiplied by 2, 12, carry 1, 6 times 2 is 12, carry 1, 6 times 3, 18, plus 1, 192, minus 49 times 3, 3 times 9, 27, carry 2, 3 times 4, 12, plus 2, 14, which equals to 192 minus 47. What is it going to? 192 minus 47 will give us 45. That will now be 45, because 2 is minus 7, but should be borrowing 1 from 9, making 8. This will be 12. 12 minus 7, 5, 9. This will remain 8. 8 minus 4, 4. Then 1 minus 1, 0. So we now have 45. We can now proceed to look for our x1 and x2. To look for x1 now and x2, we now says that now we have gotten our x1 and x2. Now, which is the determinant of x1 and x2, then what is the determinant of a? The determinant of a equals to, we now solve for only this, excluding the equals, which is 6, 3, 5, and 4, which equals to, bracket open, 6 times 4 minus 5 times 3, which equals to 6 times 4, 24, minus 5 times 3, 15, which equals to 24 minus 15, which will give us 9. That is our determinant of A. Now, we have got the determinant of x1, determinant of x2, and determinant of A. In substitution, you can even solve this determinant of A first before solving for the determinant of x1 and x2. We now say x1 equals to the determinant of x1 all over the determinant of A, which equals to, the determinant of x1 is 36, divided by determinant of A, which is 9, which equals to 36 divided by 9, we have 4, whereby x2 equals to the determinant of x2 all over the determinant of A, which equals to the determinant of x2 is 45 divided by determinant of A, 9, which equals to 45 divided by 9, we have 5. That shows that our answer gives us 5. That means x2 is 5. This answer, what you have solved here, if you want to verify what you have solved, probably you are doubting your answer, you are not too sure of your answer, then you can come here to prove it by saying proving. You don't want to prove to show that your answer is correct. Then what is the equation 1 we have? Let's use equation 1 to prove it. In equation 1 we have 6x1 plus 5x2. What is it? It equals to what? 45. Let's see, maybe we get the 45 that is equals to. You now say when x1 equals to 4 and x2 equals to 5. Now you now say 6 bracket 4 plus 5 bracket 5. So which equals to 6 times 4, 24, plus 5 times 5, 25. This will be 25. 24 plus 25 equals to what? 49, which shows that the answer is correct. Then you can move on. But for exam, in examination, you don't have to put this proof in there. This one is just for you to be certain that, oh, this answer that I've gotten is 100% correct. We move to example 2. In example 2, we'll be looking at 3 by 3 matrix simultaneous equation. For instance, let's solve this system of equation given below. Example 2, EG2. Solve and solve the system of equation given below. Now, this is the system of equation given below we want to solve. In this system of equation given below, 4x1 plus 2x2 plus 3x3 equals to 28. 3x1 plus x2 plus 2x3 equals to 20. While 10x1 plus 5x2 plus 15x3 equals to 70. This one is equation 1, equation 2, equation 3. How do we solve this? Using matrix. Using Crammer S Rule solution. Now, the first thing, let's start with the determinant of A first, before looking for the determinant of x1, x2, and x3. In the determinant of A, which says, breaking it down into equation, we have 4. This is x2, which is 1. Now, we have 4, 3, 10, 2, 1, 5, 6, 2, 15, x1, x2, x3, 28, 20, then 70. Don't forget that this used to be plus, this used to be negative, while this used to be positive. So we have plus, negative, positive. In the determinant of A, we make use of only this box, which comprises of x1, x2, and x3, excluding the equals to, which is the 28, 20, and 70. Using this now to get determinant of A. The determinant of A equals to, this is 4. 4. In 4, whenever you pick this 4, you eliminate all the same things that are on the same column and roll with 4, which we have like this. So when you eliminate them, you have 1, 5, 2, and 15. 1, 5, 2, then 15. You put a slash, negative sign, negative 2. You eliminate all what are on the same row and column with it. You have 3, 10, 2, and 15. 3, 10, 2, and 15. Then positive sign, 6. You eliminate all what are on the same row and column, also 2 with it. So you have 3, 10, 1, 5. 3, 10, 1, 5. This is what you have. Now we solve for the determinant of A. The determinant of A equals to 4 here in bracket 1 times 15. 1 times 15. Bracket close. Minus 2 times 5. This is it. Then you can now say minus 2 here. Two in brackets 3 times 15 minus 2 times 5. Sorry, 2 times 10. Is it? Plus 6 here. 6 plus 6 here. In bracket 3 times 5. Bracket close. Minus 1 times 10. Now we have this. So determinant of A equals to 4 in bracket 1 times 15. 15 minus 2 times 5. 10 bracket close. Minus 2 times 5, 2 times 3, 6. Sorry. Minus 2 in bracket 3 times 15, 45. Minus 2 times 10, 20. Bracket close. Plus, what is it? 6. Bracket open. 3 times 5, 15. Minus here, the minus sign here, 1 times 10, 10, bracket close. Determinant of A equals to 4 in bracket 5 minus 10, 15 minus 10, 5, minus 2, bracket open, 45 minus 20, 25, bracket close, plus 6, bracket open, 15 minus 10, 5, bracket close. Now you continue here by saying that determinant of A equals to, now 4 times 5, 20. 20 minus 2 times 25, 50, plus 6 times 5, 30. Determinant of A equals to 20 minus 50 will give us negative 30. 20 minus 50 will give us negative 30. Negative 30 plus positive 30 will give us 0. Will give us 0. Since the final answer here has given us 0 as our determinant, we have gotten 0 as our determinant, What does this 0 mean? No unique solution exists. That means no unique solution exists. No unique solution exists. That means there is no any unique solution that exists in such. No unique solution exists since the determinant of A give 0. Since the determinant of A gives 0. So no unique solution exists in this equation. We cannot move further by looking for our determinant of x1, x2, and s3. Because if we move further to look for the determinant of s1, s2, s3, our final answer for s1, s2, and s3 will still be 0. Because we still have to divide anything we get by this 0, which is the determinant, and it will still give us 0. So that means no unique solution exists in this kind of equation. We move to example 3. In example 3, we will still be looking at, let us look at example 3. We stated that solve the system of equation below using Crammer's rule. Now, says that solve the system of equation below using Crammer's rule. 3x plus 2y plus z equals to 10. 2y plus 3z equals to 20, which is equation 2. This is equation 1. This is equation 3. In equation 2, we notice that x is missing there. Now, equation 3 says x minus y plus 2z equals to 5. The first thing we have to do is to look for the determinant of A. Looking for the determinant of A, let us write down this equation. Let us write down the expression in matrix form. 3x we have 3, 2y we have 2, z is 1. Then in the next one, it started with 2y. In x there is nothing there, so you replace it with 0, 2y, 3z, x here 1. This is negative y. That is 1y, negative 1y, which will be negative 1. And this one is 2z, which will be ordinary 2. Then you now have what you are looking for, s, y, z, which equals to 10, 20, and 5. So that is what is equals to there. Then now we have to solve for the determinant of A, which says the determinant of A equals to, remember we have plus, negative, and here is positive. So when we pick 3, we pick this 3, then all these things we have on the same row and column with 3 will be cancelled out. So we cancel like this. We have 2, negative 1, 3, 2. Then we pick negative 2, this negative, and this 2 at the middle. We are using this first one only. negative 2. We cancel out what are on the same column and row with it. So we have 0, 1, 3, 2. Then we have positive 1. Positive 1. We cancel out what are on the same row and column with positive 1. We have 0, 1, 2, negative 1. So this is what we have there. Now we can now move further by saying the determinant of A equals to 3 in bracket 2 times 2, 4. The invisible minus that is here, I've put it here, minus negative 1 times 3, negative 3. We have this like this. Then negative 2 in bracket 0 times 2. So we have 0 multiplied by 2, which will give us 0. Negative 3 times 1, 3. We have the bracket close to here like this. We now have plus 1 in bracket 0 times negative 1 will give us what? 0. And the negative that is here before, negative 2 times 1, 2, bracket close. Now we now say determinant of A equals to 3 in bracket 4 minus times minus plus 3, bracket close. So negative 2 in bracket 0 minus 3, that will give us negative 3, plus 1, bracket open, 0 minus negative 2, that will give us negative 2, which our determinant of A equals to 3 in bracket 3 plus 4, 7, minus 2 times negative 3, that will give us negative 6, plus 1 times negative 2, negative 2. Now we can now say our determinant of A equals to 3 times 7, 21. Negative times negative, positive, will give us positive 6. Positive times negative will give us negative, we have 2, which our determinant of A equals to 21 plus 6, 27. 27 minus 2 will give us 25. So that means our determinant of A equals to 25. Now we can look for the determinant of x1. X1 determinant equals to, we come back to this place here. When we come back here, we have this box here. 3, 0, and 1, they represent x. So, okay, ordinary x, not x1. X, so we eliminate all this x figure and replace it with the equals to, which will give us 10, 20, and 5. Then others, the y and z, remains. So we have 2, 2, negative 1, 1, 3, and 2. Now we can now look for the determinant of x. Looking for the determinant of x, we now say determinant of x equals to, remember here is positive, negative, positive. So we now say 10. When we eliminate all what are on the same goal and column with 10, we have